morning. Hello.
Good morning, ma'am.
Good morning.
Good morning.
Good morning.
இன்னைக்கு அந்த மாதிரி எக்கோ கேட்குதா? பேசுறது டபுளா கேட்குதுல்ல, நேற்கலாம் நல்லா கேட்குதா? See, yes or no?
No, ma'am.
Okay. Today we are going to see multi-processor configuration. In yesterday's class, we have seen how the 8086 microprocessor works in two modes, that is minimum and maximum mode. But today, now we are going to see multi-processor. What is multi-processor? So multi-processor is nothing but multiple set of processors that execute instructions simultaneously. If there is a processor more than one, that is actually multi-processor. Okay, in the system, if we connect more than one processor, it has to be multi-processor for doing the program. Okay, so here we are going to see the three basic multi-processor configurations. Okay, that is co-processor configuration, closely coupled configuration, and loosely coupled configuration. So, ஏன் மல்டி ப்ராசஸருக்கு போகிறோம்னா சில டைம் ஒரு ப்ராசஸரால் அந்த ப்ராசஸ் ஒரு ஒர்க்கை கம்ப்ளீட் பண்ண முடியாது ஒர்க்கர் தேர் யூ ஹேவ் டு கனெக்ட் மோர் தென் ஒன் ப்ராசஸர். ஓகே, ஸோ யோர் மெயின் ப்ராசஸர் வில் ஆக்ட் as a master, the remaining processor will act as a slave processor. Okay, so for completing the task in time or to complete the task speedily, you have to connect more than one processor. Okay. First one, co-processor configuration. So, co-processor is a specially designed circuit on microprocessor chip which can perform the same task very quickly which the microprocessor performs. So, here the co-processor means one more processor with the 8086. Okay, look at the diagram and see the co-processor 8087 connected with 8086. This is your normal 8086 processor. So to additional to that, we are going to connect a co-processor 8087. So the main aim for connecting the co-processor is to perform the same task in speed. Okay, so it will maximum reduce the workload of your main processor. Okay, so the co-processor has the same memory, same input-output system, bus, control logic, and clock generator. So both the processor will have same bus control logic, memory device, input-output device, and also system bus. Okay, for working. The co-processor handles specialized tasks like mathematical calculation, graphical display on screen, etc. Okay. So co-processor வேலை என்னன்னா எந்தெந்த இடத்துலலாம் டைம் டிலே ஆகுதோ அந்த வேலையை வந்து it will do it. Okay, so instead of doing the processor, the co-processor will do all the mathematical calculation and graphical display on the screen. Okay, everything will be done by the co-processor to speed up the task. Okay, to speed up the task to complete. Okay, then the 8086 and 8088 can perform most of the operations, but their instruction set is not able to perform complex mathematical operations. So in these cases, the microprocessor requires a math co-processor like Intel 8087 math co-processor. Okay, so Intel 8087 math co-processor will complete the complex mathematical operations. Okay, so this is the math Intel 8087 co-processor. Okay, 8088 is one type of co-processor, but it will not complete the complex mathematical operations. So instead of connecting 8088, you can go with 8087. But in the diagram they shown 8087 way, it will be the complex mathematical operation. Okay. This will easily complete the all mathematical, complex mathematical operations. Okay, very quickly. Have you understood? Co-processor configuration is nothing but one more processor going to be connecting with the normal processor 8086. Okay, for improving the performance as well as to make the task to complete quickly. Okay, for that reason only you are going to add one more processor, that is the co-processor. But other than that, all the remaining peripheral devices, that is bus control logic memory, input output device, will be common for both the processor. Okay, that's our co-processor configuration. Then next we can go with the how is the co-processor and the processor connected. The co-processor and the processor is connected via test, request, grant signal as well as queue status signal S0 and S1. So here the test signal, so mono signal that is test signal, request granted, permit queue, status signal. So first is test signal. So test signal is connected to discrete pin of co-processor. The remaining 3 pins are connected to the co-processor 3 pins of the same lane. The test signal மட்டும் 8086 ல test signal இருக்கும் பாருங்க. அது வந்து discrete pin co-processor discrete pin ஓட கனெக்ட் பண்ணுவீங்க. Okay. Co-processor is 8087, 8086 is your master processor. Okay. So master processor ல இருக்க test pin will be connected to the discrete pin of co-processor. Okay, and then remaining 3 signals, that is request grant 1 signal, QS0, QS1. These 3 signals will be connected similarly to the same request grant signal, Q signal of your co-processor 8087. Okay, 8086 request granted Q signal அதே signal எடுத்து 8087 அதே signal pin இருக்குலையா அந்த பின்னுக்கு நேராவே கனெக்ட் பண்றாங்க. Okay. Then test signal takes care of the co-processor activity, that is the co-processor is busy or idle. So test signal going to identify whether the co-processor is busy or simply idle. Okay, அப்படிங்கறத டெஸ்ட் பண்ண போறது தான் உன்னோட processor, that is processor test signal. Okay, then request grant signal is used for bus arbitration. So bus arbitration, the transferring of data as well as control will be managed by the request grant signal of your processor. Okay, and then co-processor uses queue signal to track the status of the queue of the host processor. Okay, host processor and master processor na host processor, that is your 8086 processor. So 8086 plus status of the queue, instruction queue la dana irukum. So one by one only it will be executed. So under queue of the instruction will be, status will be tracked by your status signal, queue status signal. Okay. Now we go for next type of configuration, that is closely coupled configuration. Okay. So as the name given, closely means here we are going to use all the peripheral device, that is bus control logic, memory, input output device, system bus for all the processor. Same peripheral device will be used for all the multiprocessor. Okay, here they given only one independent processor, but you can connect more than one processor. Okay, closely coupled na, it may have one or more processor. Okay, that means independent processor ஒன்று தானே இங்கே காமிச்சிருக்கான் ஃபிகர்ல, but you can have more than one. Okay, நிறைய இருக்கலாம், நிறைய இருந்தாலும் எவ்வளோ இருந்தாலும் the same bus control logic, memory device, input, output device, everything will be same for all the process. Okay, ஒரே ஒரு memory device, input, output device for bus control logic தான் கனெக்ட் பண்ணுவீங்க எல்லா ப்ராசஸருக்கும். அதனால தான் இதுக்கு நேமே க்ளோஸ்லி கப்பிள்டு கான்ஃபிகரேஷன். முன்னாடி பார்த்தீங்கன்னா கோர் ப்ராசஸர் ஒன்னே ஒன்று தான் கனெக்ட் பண்ண முடியும். கோர் ப்ராசஸ் கான்ஃபிகரேஷன் யூ கேன் ஏபிள் டு கனெக்ட் ஒன்லி ஒன் ப்ராசஸர் வித் அடிஷனல் டு த மெயின் ப்ராசஸர். ஓகே, நிறைய கனெக்ட் பண்ண முடியாது. கோ ப்ராசஸர் கூட இன்னொரு கோ ப்ராசஸர் கனெக்ட் பண்ணிட்டே போக முடியாது. பட் இங்கே வந்து பார்த்தீங்கன்னா in closely coupled configuration you can connect one more independent processor. இன்னும் 10 கூட கனெக்ட் பண்ணலாம். ஓகே, பட் 10 கனெக்ட் பண்ணாலும் bus control logic, memory device, input output device இந்த மாதிரி peripheral device will be same for all the 10 microprocessors. Okay, that's why it's named closely coupled configuration. Okay, so closely coupled configuration is similar to the processor configuration, that is both share the same memory, input output system bus, control logic and control generator with the host processor. However, the core processor and the host processor fetches and executes their own instructions. The system bus is controlled by the core processor and the host processor independently. So that is nothing but the core processor will have some set of instructions to execute and fetch. அதே மாதிரி இதே independent processor also will have set of instructions to execute and fetch. Okay, but the system bus will controlled by your core processor, but the host processor will work independently. Okay, so your core processor will depend on host processor for all the process in the co-processor configuration, but here in independent processor it will be independent in all the work, all the tasks with the host processor. Okay, so host processor depend பண்ணி இல்லாம it can be able to work independently. That is why it is called independent processor. But our co-processor பார்த்தீங்கன்னா it will depend on processor for all the performance of tasks. Okay, this is the difference between the co-processor and independent processor. Co-nave must be work with the other processor. Okay, இல்லைன்னா தனியா இண்டிபெண்டா ஒர்க் பண்ண முடியாது. அதனால தான் அதுக்கு நேமே co-processor. But here it's named as independent processor. That means it will not depend on the master processor for all the work. So now we are going to see how is the processor and the independent processor connected. So communication between the host and independent processor is done through the memory space. Okay, so none of the instructions are used for communication like wait, escape, etc. இந்த மாதிரி instruction எதுவுமே யூஸ் பண்ண போறதுல communicationக்காக. Okay, the host processor manages the memory and wakes up the independent processor by sending commands to one of its ports. So host processor going to manage the memory device, and then it will activate the independent processor by sending some commands to the port, input output port. Send பண்ற மாதிரி இந்த போர்ட்டுக்கு இதோட the device ஓட போர்ட்டுக்கு எந்த சிக்னலாவது அனுப்பி command signal will be sent to the independent processor by the host processor to wake up the or activate the independent processor. Okay, then after activating the independent processor, what the independent processor will do? It will access the memory to execute the task. என்ன பண்ணோம்? independent processor வந்து activate பண்ணியாச்சு. So independent processor wake up டா இருக்கு. Okay, so after it will be able to access the memory device for executing the task. Okay, after completion of the task, so இப்போ இந்த task வந்து complete பண்ணிருச்சு. இது independent processor வந்து task முடிச்சிருச்சு, and then it will send the acknowledgement to the host processor by using the status signal or an interrupt request. So what it will do, the independent processor will send the acknowledgement signal to the main processor, that is host processor, that I had completed my task. Okay, அப்படிங்கிற ஸ்டேட்டஸை சென்ட் பண்ணும். இல்லைன்னா என்ன பண்ணும், இன்னொரு இன்டரப்ட் சிக்னலை இது சென்ட் பண்ணும். அப்போ இன்னொரு இன்டரப்ட் சிக்னல் சென்ட் பண்ணதுனால என்ன ஆகும்? இன்டரப்ட் சிக்னல் வருதுனாவே இட் ஆஸ்கிங் ஃபார் ரெக்வஸ்ட். ஓகே, ரெக்வஸ்ட் வேற ஏதாவது ஒர்க் இருக்கா இருந்தா குடு அப்படிங்கிற மாதிரி it will be setting the interrupt request for the post process. அப்பனா என்ன previous work is done அப்படிங்கறத inform பண்ணும் post process. Okay, so if there is a work for doing means you send to me அப்படிங்கற request தான் இது independent process and post process க்கு அனுப்பும். சரியா? So this is the diagram of co-processor configuration. இது co-processor configuration ஓட architectural diagram. Okay, see there you will be having 8086, co-processor 8087, and then 8288 bus controller, 8282 latches, 8286 transceiver, etc. So bus controller, latches, transceiver, programmable interrupt controller. Okay, இதெல்லாம் பார்த்தீங்கன்னா other peripheral device which is used for multiprocessor configuration. Then now we are going to see the loosely coupled configuration. So in loosely coupled configuration, we have separate memory as well as input-output device, bus control logic, everything will be separate for each process. Okay, இது பார்த்தீங்கன்னா உங்களுக்கே தெரியும் ஒவ்வொரு பாக்ஸ் கொடுத்துருக்காலையா, ஒவ்வொரு ப்ராசஸுக்கும் தனித்தனி மெமரி, லோக்கல் மெமரி, லோக்கல் இன்புட்-அவுட்புட் டிவைஸ், local bus control logic, அதே மாதிரி system bus control logic. Okay, everything will be separate for each processor. ஒவ்வொரு ப்ராசஸுக்கும் தனித்தனியா கொடுத்துருக்கோம். பட் க்ளோஸ்லி கப்பல்ல அப்படி கிடையாது. எத்தனை ப்ராசஸர் நீ யூஸ் பண்ணாலும் அத்தனை ப்ராசஸருக்கும் the same memory device, same input output device, same bus control logic, system logic will be used. Okay, ஆனா இங்க மாடியூலா யூஸ் பண்ணுங்க. ஒவ்வொரு மாடியூல்லையும் ஒவ்வொரு ப்ராசஸருக்கும் செப்பரேட் peripheral devices will be allotted. Okay, so இது எல்லாத்தையும் integrate பண்ணி தான் you will be connecting to the system memory, system input output devices. Okay, so the entire module will be called as a system. Okay, system, the entire system will be connected further to the system memory, system input output devices commonly. Okay, so the entire system will have different modules. So each module will have separate processor with the separate memory devices and other peripheral devices. Peripheral devices na additional devices. Okay. So this is the difference between closely and loosely coupled systems. So loosely coupled configuration consists of the number of modules of the microprocessor based system which are connected to a common system bus. This is the common system bus which will connect the all modules, okay, in the system. So each module consists of their own clock generator, input output device, memory device, and are connected through a local bus. Okay, so each module will have local bus. This local bus will be connected to the common bus for further communication. So what is the advantage of using loosely coupled system? So having more than one processor result in increased efficiency. So efficiency will be very high in this configuration. So each of the processor have their own local bus. Okay, over processor will have own local bus to access the local memory input output device, which will make it to achieve parallel processing. So parallel processing and the way time will be saved. So it can be able to complete the task easily. Okay, the system structure is flexible. So இங்க வந்து ரொம்ப structure பார்த்தீங்கன்னா loosely coupled. Loosely coupled means easy connect பண்ணலாம். ஸோ எங்கேயாவது ஒரு மாடியூல்ல ஏதாவது ஒரு ஃபெயிலியர் நடந்தா யூ கேன் ரீப்ளேஸ் த ஃபெயிலியர் ஈஸிலி. ஓகே, அப்போ ஈஸியா மாத்திட்டு யூ கேன் ஒர்க் இட். ஓகே, ஆனா இதே பார்த்தீங்கன்னா காம்ப்ளெக்ஸ் சிஸ்டமா இருந்தா என்ன ஆகும்? க்ளோஸ்லி கப்பிள்ட் சிஸ்டம் எல்லாம் எந்த இடத்துல ஃபெயிலியர் அக்கர் ஆகிருக்குன்னு கண்டுபிடிக்கிறதுக்கே கஷ்டமா இருக்கும். ஸோ இன் தட் கேஸ் யூ கேன் easily replace the failure and do the work easily. This is the advantages of loosely coupled system over your closely coupled system. Okay. So any doubt in the multiprocessor system? So multiprocessor is nothing but more than one processor going to connect to the system. Okay. Here you will be having three basic multiprocessor configuration: co-processor, closely coupled, and loosely coupled configuration. Co-processor means only one processor going to be added with your main processor, that is first processor, and then that two processor will have the same peripheral device for performing the task. But closely coupled systems have more than one independent processor, that is host processor இல்லாம ஒரு independent processor யூஸ் பண்ணலாம், அதுக்கு மேலே யூஸ் பண்ணிக்கலாம். பட் ஆல் த processor will have same use same memory device, input device, everything, peripheral device. Okay, so என்ன டிஃபரன்ஸ்னு பார்த்தீங்கன்னா co-processor depend on host processor. Okay, but closely coupled பார்த்தீங்கன்னா you will not having co-processor, it will be working as a independent processor. Okay, so one more processor add பண்ணா அதை வந்து host processor depend பண்ணி இருக்கணும்னு அவசியம் இல்லை. It can be able to work as a independent processor. அதை டிபெண்ட் பண்ணாம எல்லா வேலையும் அதே பார்க்க முடியும். ஓகே, இதுதான் டிஃபரன்ஸ். அடுத்தது லூஸ்லி கப்பிள்ல பார்த்தீங்கன்னா ஒவ்வொரு ப்ராசஸர் கனெக்ட் பண்ணுறீங்க இல்லையா, அந்த ப்ராசஸருக்கு செப்பரேட் memory device, input device, and other peripheral device will be having as a module. Okay, so each module will be connected to a common bus system for doing the task. So this is the difference of multiprocessor configuration. Any doubt? If you may ask now, question now. Okay, you are having 10 more minutes.